All right, so let's talk about part 3 in the basic right triangle series. So we've already kind of gotten more comfortable with the fact that there are 6 trigonometric ratios, and we've practiced how to find those ratios if I have all the sides of a triangle. And today what we're going to do is we're going to practice a little bit how to solve for specific things, and then how to solve for the angle that right now has just always been a variable, like a theta or a beta or an alpha. So let's kind of look at an example, right? So let's say I have this situation, and I'm going to actually change this. And now I'm going to tell you that this is 30 degrees. Okay. So you can fill in a lot of information, but we're not as concerned about filling in the information as we are right now about solving for x. Okay. So our goal here is to solve this equation for x. Now, some of you are great at solving equations, some of you struggle with solving equations, and some of you fall somewhere in between on the spectrum. And part of what we're doing here is we create the strategies that you need to be successful. So I'm going to look at this and I'm going to say, well, I have opposite and I have the hypotenuse. Okay, so if I remember back to the previous thoughts, that is the trig function sine. So I'm going to write the sine of 30 degrees, and I'm going to put that over 1 just to make it into a fraction to make it a little bit easier. So most of you probably just heard me say, you just said make a fraction so it's easier. It's not. But in this situation, I might have a secret weapon. So the sine we said is opposite, which in this situation is x, over hypotenuse, which in this situation is 12. And I'm going to highlight those just so that we can recognize that opposite was red and hypotenuse was 12. I just want to make sure we see what we're doing. So from here, okay, there's a variety of ways we can solve an equation like this. But for most trig students, I recommend cross multiplication, okay? And the reason I recommend it is because it's something like that you're just comfortable with, okay, or proportions. So we're going to do 1 times x, which is x. We're going to keep the equal sign, and then we're going to do sine of 30 times 12. And writing this out is kind of a little bit weird, but we want to make sure we're using parentheses, that we're being super cautious in what we're writing, and we're being really careful. In this example, it's pretty straightforward because this is just a multiplication fact that we have to use, and we can use our calculator to figure out what the sine of 30 degrees is, and we'll practice this in class, but I'll tell you for now that it is 1/2. Okay, so the sine of 30 is 1/2, or 0.5 if you're more comfortable with that. So this problem became x equals 12 times 1/2, 12 over 1, and when I get that, I get x equals 12 over 2, or x equals 6, okay? Now, if you needed a calculator to do 12 over 2, perfectly fine, not a problem. Not going to fight with you, don't care, okay? But just something to think about, okay? The next kind of problem we're going to look at is what if the x is in a different spot, right? What if it's in the denominator instead of the numerator? So let's take a look at that. So let's do a different example. And this time we're going to do 30 degrees up here. And I'm going to tell you, no, let's not do 30. Let's make this 45 degrees. Okay, so that's 45 degrees. And this is going to be This is going to be 18, and this is going to be x. Okay, so from here, we're then going to say, okay, I have opposite and I have the adjacent, which means the trig function we're going to use is tangent. So we're going to use the tangent of 45 degrees equals opposite, which is 18, over adjacent, which is x. And we're also going to put the tangent of 45 over 1. And I apologize, my neighborhood has gotten very busy this morning. And we're going to apply the same philosophies that we did before. We're going to cross multiply. So we're going to do 1 times 18 and tangent of 45 times x. Okay, and notice I'm putting that in parentheses so that I don't try to screw things up. Okay, I make mistakes all the time. So now I'm going to go to my calculator and I'm going to try to figure out what the tangent of 45 is. I happen to know that this is 1, so it's going to become 18 equals x times 1. Let's say it had been 5, then it would be x times 5 or 5x. And then using our inverse operations, we're just going to solve. So we're going to divide by 1, divide by 1. So in this situation, x equals 18. This is a very special situation. And there's some of you that very quickly will figure out that x equals 18, and there's some of you that would have to solve that out every single time, and that's perfectly fine. Okay? We have one more type of example to talk about, and that's how do you solve if you want to find the angle. Okay, so the last thing for now is using what's called inverse trig functions. Now, it gets a little confusing because we've talked about reciprocals. Okay, so reciprocal means to flip the fraction. Okay, an inverse means to switch the domain and range, which is a lot more complicated. Okay, the short thing you need to know is that when we switch the domain and range, there's just a procedure we're going to do in trig, okay? In other classes, we've spent more time on what that means to swap the domain and range and to swap the x and y values. It's less in this situation. In this class, what you need to realize is it means you're solving for an angle. Okay, that's what you're doing. You're solving for an angle. And so let's draw ourselves a picture. This is now theta. This is now, let's say, okay, so let's say that you have something like this picture and it has a 12 over here and a 24 over here, okay? So if I was to write out my equation the way that I understand it so far, I have opposite and I have hypotenuse. So it would be the sine of theta equals opposite, which is 12, over the hypotenuse, which is 24. Okay. The problem here is, notice that for up until now, we always solved this. We knew this number, this theta value, and we don't know that now. We need to find it. So we're going to rewrite this as theta equals the sine inverse of 12 over 24. Okay. And I don't have access to my calculator right off the bat, which is partially why I chose this problem. But what you would do on your calculator, okay, is you would find the sine inverse, which we'll practice in class. So we'll do the sine inverse of 12 over 24, and you would just type it right in your calculator, and it will produce that this is 30 degrees. And so your calculator would tell you that this is 30 degrees, and we would know that this was, the answer was that 30 degrees. Okay? Hope these help, and we will continue to practice these skills in class. Good luck.